Hello and welcome back for the video for lesson 2.7 for Math 151. This is all about transformations of the graphs of functions. The first kind of transformation we're going to look at is called vertical and horizontal shifts of the graph. So horizontal shifts are left and right shifts on the x-axis. There's shifts when you're making a change to the input before you evaluate the function. So you're adding something to x or you're subtracting something from x. Vertical shifts are shifts that happen up and down on the y-axis. When you it's visually when you transform the x input outside of the value is evaluated. So your output, you input x, and then you're actually transforming the output. So let's look at a couple of examples. The first example says, let's look at the function of the absolute value of x, and then let's transform the function of absolute value of x by adding 3 to it. So I have these inputs of a -3 to 3 here on the table. And if we put in a -3 of the absolute value, we get 3. If you put in a -2, you get 2. A -1, you get a +1. 0, 1, 2, and 3. Okay, and in general, that graph looks something like this. Right at the origin, it makes a V. Now, when you take the absolute value of x and you add 3, it means you're evaluating the absolute value of x, so what we have over here in f, and then you're adding 3 afterward. So you would add 3 to this absolute value of x, you would get 6, add 3, you would get 5, add 3, you get 4, 3, 4, 5, and 6. And so the newly transformed graph is a shift on vertical up 3. So it's going to look the same. It's just going to be shifted up 3. So let's see that in Desmos. For this lesson, for your notes, assignment, you're expected to input these into your own Desmos and save them, and show me that you understand how to do that. So this initial absolute value of x at the origin is here. And then if I add in the absolute value of x plus 3, notice that it shifts up. So the green line is shifted up blue. Okay. Let's go ahead and look at example 2. Example 2 says, use vertical and/or horizontal shifts along with the table of values to graph the following functions. Start by deciding what the base function is, and then follow by choosing what the shifts are. So this says the square root of x plus 2. So my base function on this one would be g of x equals just the square root of x. And what does that look like? So if I have just the square root of x, I'm going to put in some values for x that I know the square root of. So I know this 0, if x is 0, I know the square root of 0 is 0. And the next one I know is 4. The square root of 4 is 2. The next one I know is 9. The square root of 9 is 3. And actually, we also know 1. The square root of 1 is 1. Okay. So that graph, and we can't take squares of a negative number, so we know they all have to be +0. So let's go to Desmos and see what this would look like. So example 2 is I'm going to the menu here, and I'm putting in the square root of x as my base equation. And I'm going to turn that graph on over here, and there's my base equation. And then I'm going to copy that and I'm going to adjust it. So in the notes, we have the one that's been transformed is the square root of x plus 2. Let's just go back to our paper for a moment and look at that. And let's make a guess at what's going to happen. So x plus 2, I'm changing the input before I take the square root. In words, I'm changing the input before the square root. Okay, so I'm changing the input. That means I'm changing everything left and right. So this is going to be a horizontal shift. And because I'm adding to, you can see here that you're shifting the graph to the left because we're adding. So it's a horizontal shift left. Let's go ahead and look at that in Desmos. I'm going to edit that. So we've got the horizontal, the square root of x plus 2. Oops. There we go. And it indeed did shift it left. So 2b turn off those graphs here. So 2b, the base function is going to be the absolute value of x. Because so base is going to be the absolute value of x. And then we have the shift inside that's going to be the horizontal shift to the left 3. And then after we take the absolute value, we're going to shift it -2. So that means we're going to shift it down 2. So it's going to be a vertical down 2. So let's look at that. Make sure you're typing all of these into Desmos and saving them because it's going to be part of your note submission. So in 3, we have the absolute value, or 2b, we have the absolute value of x. And then I am going to copy that. And inside that absolute value, we are going to add 3. So that did shift it left. Okay. And then I'm going to copy that. So I'm going to have 3 entries here. And then after I shift it left, I'm going to subtract 2 and it shifts it down 2. So we shifted from the black to the red to the blue. So to the left and down. Let's go. The next type of transformation that we're looking at is vertical scaling and translations. So we scale a function vertically when we either stretch it or compress it outside of the function. Okay, when we talk about scaling, it's kind of like if you were making a recipe of cookies and you said, oh, I've got extra people coming, so I'm going to double my recipe. You have just scaled your recipe up by 2. Or if you triple your recipe, you're scaling your recipe up by 2. You're multiplying by 2 or multiplying by 3. And that's what we're doing here. Notice that we're multiplying c on the outside of the function. So after we've evaluated the function, we're multiplying the y value. So that's why it's changing vertically on the y-axis. Let's write that down on the y-axis. So if c is bigger than 1, it's going to be stretched vertically. It's going to get skinnier. So it magnifies it and makes it appear bigger. Okay. If the c is between 0 and 1, so it's becoming a fraction, then it is compressing vertically. It's shrinking down. Okay, so let's look at example 3. I've got some examples of that. I also have an example 3, what is called a reflection. That's at your last page of notes here. So it says we reflect across the x-axis when the graph of g of x equals a negative f of x. So that's called a reflection. We're reflecting vertically from top to bottom. So it says we scale a function horizontally when we either stretch or compress it outside of the function. I'm sorry, we're compressing it inside the function. So we're compressing it inside the function. And that is when we're multiplying it here by the inside. And then if c is bigger than x, it's stretched. It's getting magnified. And here, if it's multiplied by x. So let's look at a couple of examples here. So I'm going to start with this base function of the absolute value of x. When we multiply inside the function, it is going to be a horizontal stretch. So I'm going to show you what that looks like. See how it looks steeper? I'm going to change the colors on that so you can see a difference. Okay, so the blue one is steeper because you're changing the input of the function. Now, if I were to take that same function, the same absolute value function in red, and this time I multiply it afterward by 3, it gets stretched, it gets pulled up again. Okay, so multiplying or scaling up definitely makes it bigger and going up more. Now, if I were to make that instead of a 3, I made that a 1/2, something between 0 and 1, notice it opens up more like a V, like a wide V, more like a U or like a flower, how it opens up. So when it's more of a fraction and the fraction gets closer to 0, so if I made this to 1/8, it gets even flatter, or 1/10, it gets even flatter. So the smaller that fraction, the C or the scale gets to 0, it gets flatter and flatter. Now, if we turn all of these off and just look at the absolute value function, and I look at where I am reflecting. Reflecting means I'm taking a negative on the outside, so I'm going to do that here. So it just flips it over across the x-axis, which is a vertical reflection. Okay. So if you look at example 4 on your paper, these are just graphs. So you're just kind of observing what's going on. So the base graph in number 4, I'm going to turn this off. The base graph in number 4 here on Desmos, I'm going to make that to be just a y². So let's see here. I'm going to take away the scaling and the reflection. So there's just a parabola. We're going to learn more about those later, but there's a basic y² function. And then you can see here, if I take that, and I scale it up by 3, it gets sharper, more like a V. And then here, if I take in the negative of that, it flips it over the axis. It's pretty cool, isn't it? Okay. Then if we go down here, and I'm going to turn those off, and we go back to our absolute value function. So here's our raw absolute value function. We're looking at example 4, B as in boy. So our base function is an absolute value function here. And then by subtracting 1 on the inside, we're actually moving everything right 1. So let's go ahead and check that out if we were to do that. So subtract everything when I shifted everything from red to blue. So we shifted from the red to the right, or from the left to the right, red to blue. And then if I take a negative of that and add 2, so let's go ahead and first add 2, so that's going to shift it up to the green. And then I'm going to turn on the last one here with the negative out front. It actually reflects it over the axis. So here's from the actual reflection from where it's face up to face down. So this lesson is all about graphing and what the operations that we're doing to our function actually do to the graph of the function. So catch me back for lesson 2.8.